All right, good morning, everyone. Let's get started with today's exercise. So last Friday, we did not have an in-person meeting. I did ask you to watch a video and get started on the yield editor wrangling side of things. So basically, we have a yield monitor data from a cotton picker that we just have all these points in space, and we're going to use that for cleaning that and making better sense of that data, because that's really going to be the basis of everything we do as far as variable rate management in this field. I believe I may have mentioned this on the video from Friday, but yield monitor data, it's one of those very important pieces of information that we have in precision ag, because we can use them before we implement any precision ag approach, as far as just learning about the variability on that field, also that variability across time. So if we have yield monitor data across multiple years, we can use that and learn from that as well. And once we learn something from that variability, implement some sort of variable rate management, then we can use again yield monitor data to check on that, right? So to check if what we did had a positive impact, if it had an impact at all, or perhaps if it even had a negative impact compared to just a flat rate type of approach. All right, so let's to get started here, I want to invite you to go to that 07 yield monitor project folder that I asked you to create and work from last video. I just want to make a comment here is that on that video, there was a quiz. If we were to have that class live, I would have applied that quiz. I only had a couple or maybe a few of you actually sending me the email with the answers to the quiz. And because it wasn't very clear, I guess, from my side that you should do that, I'm just going to use that quiz as an extra credit for those that did submit. If you did not submit, then I guess that's okay. But those that did submit are going to receive that as extra credit. All right. So I hope that you were able to create the structure like this. So please go ahead and launch your 07 yield monitor script. Or sorry, not script, the project. So launch your project. Once you are in the correct project, we want to come on the code folder and launch that 0209 wrangling partial script and keep going from there. If you are seeing like me where your environment is empty, you're going to have to rerun your chunks to get those variables here, and that's okay. We can go ahead and do that. And just a quick recap here. So we're taking the CSV yield monitor data. So CSV, right? It's not a geospatial data yet. It is not a vector, it's not a shapefile, not a GeoJSON. It is a CSV. That's how it was exported. So we're basically going to do some quick wrangling on that before we actually apply any types of filters, as you all saw on the assignment. So if you just follow with me until the point that we stopped on that video, we're just loading some packages here. I think you should have all of them already at this point. We're reading that data. I think actually here, I need to change. So whenever, I guess this was one difference from the video, from the recording to our actual data is this year I renamed that data set to 07 yield 17. Just make sure that you get that difference in your script. You should, once you run that, you're going to have this data set with about almost 32,000 data points or rows and 18 columns. So these columns here are very common to be reported by yield monitors. So we have heading, elevation, distance, duration, speed, fuel usage, moisture, mass of cotton, width, if it's engaged or not, mass yield, wet yield, dry yield, a timestamp, and also the coordinates here in point X and point Y. We did a quick summary here just to look at that statistical summary. Remember that we always use the summary here to look for, problematic values. So of course, there's a lot of information here, but one that I hope you notice was the dry yield. We had some very high yields here, which I guess, this being pounds per acre. Perhaps you could have fields that have this much yield, but it's not really the case here. This is a very high maximum value for this yield column, and that's how we know that we have to do something about it. And as you read in the paper, it is common for your monitor data to have erroneous data points, right? So that's why we're going to go through the process of cleaning it. We just did some density plots to look at that data distribution. So here, dry yield, we see that most of it is perhaps average around 1,000 to 100 sort of pounds per acre. But then we have this very long tail with one observation being above 4,000. We did the same for speed. We noticed that most of the speed was probably here between 4.5 and 5 miles per hour, but there were some very low speeds as well on this tail end of this distribution. We looked at this yield map, which right now we're just plotting X and Y as the coordinates. So remember, at this point, EO17 is just a data frame. It is not an SF object. So it's, even though we have those coordinates and we can kind of make a map, it's not a geospatial vector data yet. Yes, Doug?
So the data, or the color scale that you have, I have the same thing typed in the Veritas feed, and my color scale is different. And it was different than the one on the video too. It's just, it's straight blue. There's no, I don't have yellow or gray. It's all just different shades.
So you mean like in the map itself or also on the legend?
But
In the legend, you don't have all these? Huh.
and I have, wait, I might see what I did now. I feel instead of.
Oh yeah, that must be it, because we're changing. Yeah, so we're changing the color of these points, so then we have to change that scale with scale color.
That I had scale fill instead of scale color.
So have you changed the color?
It did change.
Yeah.
I could not figure that out.
Yeah.
And then I did.
Yeah, that's one of the, I guess it's worth taking a moment here and just thinking about that. So every time that we use any of these functions starting with scale, so it could be scale underscore color, fill, size, shape, or alpha for transparency. We always, the goal with those is to change more, to tailor, I guess, to your liking, whatever you're changing inside AES, right? So if we're changing color in AES, you have to use scale color here, right? So if it says scale fill, it's not gonna work if you're not using fill in the AES function. So now that you did change that, did it match? Okay. All right, so however, one thing to notice here is we have this one point, a very high yield. We can kind of see it in this map, is right there. And that's what's really skewing all the colors of this color scale, right? So we have that one single point yellow there on the left side, and that's skewing the whole color scale here. So just on the fly, so we're doing this filter here just for visualization purposes. We're really not applying this to the actual data set that is saved to an object. We're just doing on the fly. This filter is not being saved to the object. So if we just do that filter and visualize it, just by removing any yield points that are greater than 3,000 pounds per acre, now we can see more patterns in this field, right? Because we removed that single point, or maybe more than just that one, but that one was the really problematic one that was skewing the color scale. And now we can really see more of that variability on this field. However, up until this point, this is not a geospatial object yet. And then I think this is a really interesting plot, which is just plotting yield by speed. So we have speed on the x-axis and dry yield on the y-axis. And we can really pick up on some of the concepts that perhaps you already learned from the paper, which is we have these high yielding points, especially when speeds are very low, right? And as you read, when speeds are either really low or really high, or there is a shift from very high to low or low to high speeds, we have these behaviors that create erroneous data points, right? So we do not have reason to believe that yield was actually this high in that part of the field. It was probably just an issue coming from the speed being very low when that part of the field is being harvested. Okay, so then we decided, we just printed the data here to decide what do we need to do to this data set to wrangle it, to make it more usable for us. So at this point here, again, we're not applying any of the filters. We're just getting this data into the right format in a more standardized way, just for us to keep wrangling. So a few things here that I'm proposing, and I do want to, I guess, call your attention here to the point that every time you work with data, there's going to be some type of wrangling. It could be very simple. It could be as simple as just maybe selecting some columns. It could be very complex. I don't think we came across a very complex example yet, but every time you play with data, there's going to be need for some wrangling. In this case here, what I'm proposing is that we standardize the column names. We select only the columns that we need, which would be speed, dry yield, point X, and point Y. We rename the columns to include the measurement units. This is something I always recommend, and I do myself, because especially, if you're working in English units and then you change that to metric units, and if you don't have the actual units in the column names, you may not know what are the original units of those measurements. So it's always good to have the units in the column names to make it very clear. So rename the current columns to include the measurement units, create columns in the metric system, and transform into a spatial object. Remember, as of now, this is a data frame that came from a CSV file in your computers. So we want to transform this to a geospatial file, to a geospatial object first in R, and then export that to a geospatial file in your filing system of your computer. And then we want to change this from geographic to projected as well. I believe we've went through this chunk here, the last thing that we did in that recording. So I just want to quickly walk you through what's going on here. So we're starting with yield 17. We're assigning that to yield 17 and square W. So we're not overriding, right? We're just creating a new object and adding the W to mean that it was wrangled. We're applying the clean names to get those names standardized. We're selecting the columns that we want, and we're adding the unit names to them. So the select function here is selecting speed and renaming it to speed miles per hour, selecting dry yield, renaming it to yield pounds per acre, and then selecting point X and point Y. Then we're transforming here yield and speed from English to metric system. And then this part here is really where the geospatial wrangling side of things happen, right? So if we have, in this case here, we do have a CSV file or a CSV file in your system that becomes data frame in R that has two columns there that represent the coordinates, right? So point X and point Y are the actual coordinates in WGS 84. So we have to first transform it to an SF object by using this function st as SF, and then we mention what are the columns that have the geospatial location of those points, in this case, point X and point Y. Then let me just run until here. So I'm going to block this pipe here and run until this point and just print yield 17 at this point. We should see that there's no CRS, right? So remember, this was a CSV file in your computer. CSV files do not come with a CRS information with them, right? So we do have to assign the native CRS, which in this case was WGS84. The EPSG for that is 4326. So we have to assign this, the original CRS to it first, which happens if we run until this point. It's going to print that. Now it has a WGS84 CRS. And then we change it. Then we transform it to whatever we want. I'm changing this to a projected CRS. That's the UTM N8083, zone 17 north, if I remember right, for this field here that is in Georgia, or sorry, zone 16 north. So this field was on zone 16. So, just these three functions are going to be very common for us to use. So set or transforming from a data frame to an SF object using STSSF, assigning the original native CRS using ST_set_CRS, and then transforming this using ST transform. So if you make sure you run this, so you have this object, if you print it, now you should have, still all the rows, almost 32,000 rows. We should have now 5 columns, so speed, yield, both in English and metric units, and then your geometry column, right? So now we don't have the point X and point Y anymore. Those became the geometry column of the SF object. And if you come on the first panel here, it should say N8083 UTM zone 16 north. Or actually, let me think about it. Maybe in the video you did not get to the quiz, now that I'm thinking about it. Or did you? Can you remind me of that? We
didn't make it interactive.
We
Okay.
didn't get to the quiz.
Sorry, somebody said something online?
Yes, we did not get to the quiz.
Okay, so my bad. I thought that you had gotten to the quiz. So I guess ignore what I said about the quiz. So we're gonna take, if you have not taken the quiz yet, we're gonna take it today in class. Okay, so we did let's see. So we have here the static map. See here on my code. So did you get to the static mapping class? No? Okay. So let me, I think I left that for you already, that piece of code. Because it's basically it's very similar map to what we did initially, like when we were doing the EDA. The only difference here is that, well, let me, because now I may be assuming something. So do you all have this code here for the static map? Okay, so I did leave that for you, great. So the only difference here is, so we're still doing that filter of yield less than 3,000 pounds per acre, just so we can visualize better the color. And then instead of bringing a geom point, which we did originally, we're bringing a geom SF, because now this object is an SF object. So we can bring geom SF, we just determine what's the color, what column we wanted to color by, and then just changing that to varieties. So here we can really see now that because we're using a geom SF, because it is an SF object, we're actually able to see the shape of this field in this, I mean, the data looks like it fits in the field that we've been working with, which makes more sense. All right, so one thing that I think it's important for us to do is, especially when working with maps in R, if you're used to working in ArcGIS, QGIS, whatever it may be, that interactivity with the map is front and foremost. Whereas here in R or Python or any programming language, that is not the case, right? So we need to call these maps to be able to interact with them. And that's what we want to do here in this next chunk. So I left you a little bit of the code there already. So if you want to start coding with me now, we're going to add a pipe here. And what function have we been using for interactive maps? Map view, right? So let's call map view here. We do not have to specify the data, as the data is already coming through the pipe flow. I do want to, so if we just run that, we can just do it and inspect, see what happens. This is what we get. So it's not, let me reduce my size here so we can see better. So even if you come and you zoom in, there's going to be a lot of points there, but the point size is kind of big. They're not colored by yield. So it's really a not very informative map, right? So let's make this a better map. So if you come back to map view, first thing I want to do is I want to change the color of this map to be according to yield. So if we just bring that yield 17W that's coming through, that column, we can do it with the pounds per acre. So it could be yield pound per acre. The way they specify that in a map view is by calling this argument called z_col for color of the z dimension. We need to give quotation marks and we can say yield underscore pounds per acre. So if we run that, now we do see that our points are colored by, especially if we zoom in, we see that they're colored by yield. So we see that pattern, not those patterns in the field, but I think we can still make this map better. So one thing I want to change here is change the transparency and size of these points. So let's change transparency first. We can add a comma there, hit return. Transparency is referred to as alpha. So here in map view, there's an argument called alpha.regions that I want to change it. I have in my code changed to 1. So let's try that and see what that does for us. It should actually make it more solid. Yeah, I think that's what it happened. That's what happened. So maybe let's keep that for now. To change the size of the, so next thing I want to do is change size. Let's add a comma there. In map view, as we already talked about, so map view was not made by the same people that made ggplot, so it doesn't follow the same patterns, I guess, or the way that we call things are a little bit different. So if we wanted to change the size in ggplot, we would call size equals to something. Here, that argument is called CEX. That I just want to change CEX to 0.1. So that's going to change the size of the points. So they're a little bit smaller now, but still there's something that's bothering me is that it's a little bit hard to see the actual color of the point because the size of the outline of the points, it's so like it's taking so much of the attention, I guess. So let's change that next thing. So if we come here to CEX, add a comma, hit return, there is this argument called LWD, which I think stands for line width, that I just want to say equals to 0. So LWD equals to 0. All right, so now really we can see through, or not see through, but we can really we're really able to see what the point color actually is and not just, being, I guess, taking that line width taking so much attention from our map, our points. The next thing I want to do here is change the map, the base map. So I do want to have the Esri world imagery. There are a couple of ways you can do this, as you probably already know. So one would be to come on the stack here, a symbol on your map view and just select the Esri world imagery. So you can see this in context. However, if you go by this, you always have to do this manually. You always have to come to the stack and select Esri. We saw already in another exercise where we changed this behavior on the default, right, of that function. So if you come here and you add a comma, there's going to be this argument called map.types that we can just give any of the names that we see here on this stack. It has to be exactly the same way that's spelled out here. So the E must be uppercase, the W and I must be uppercase as well. So I'm going to type here on my side because I can see on my other scripts. If you just want to copy from the screen, you're welcome to. So esri.world imagery, where E, W, and I are uppercase. So if you run that, then you set your default to be that map type, that base map, and you don't have to, oh, I got an error there, worlds. Okay, so So we have your map view there. You can zoom in. As you zoom in, you're going to start seeing the points more closely. You can zoom in and zoom out and kind of inspect this. You can also, here on your legend, you can toggle on or off the yield data, so we can kind of have an idea of what's behind it. And really today, or not today, but I want to stop here for a moment because I do want to apply the quiz. So again, I apologize for my own confusion. I thought that you all had a chance to go through the quiz, which was not the case. So if you have already answered the quiz, you don't have to re-answer it. But for those of you that did not answer it because we did not get to this point on the video, I do want you to answer this quiz and send your answers to my email. So here's the question. Where in the field do you see low yielding areas? Of these different low yielding areas, which ones do you think can be related to yield monitoring errors and why? So this is going to build up from what you read on that paper, from what you wrote on the assignment related to the yield editor questions and paper. So I do want you to think back on that as you answer this. And a quick tip here is for you to toggle the yield layer on and off, and that may give you some background on behind the scenes of what's going on here, so you can, have a better way of creating some hypothesis for this case. I'm going to give you 5 minutes. You can directly answer this to my email, so just send me your answer by email. Here's my email if you don't have it yet. And this will also serve as your attendance. So I guess for those of you that have already sent me the quiz or that have already answered the quiz from the video, you can just send me an email saying that you were in class, because you don't have to send me your email saying, with your quiz answers. So here's the quiz question. I will open here 5 minutes timer on the screen, and then we're going to go from this. All right.
Professor, can you go back to the previous code where before the map, because I didn't catch up. It was too fast.
Before the map,
Right here,
okay.
where Esri image. Thank you.
Yeah. I think so, just because of that base map. Are you getting the same issue? Did you try to rename the file? And is it working now, or? Okay. Okay, nice. Yeah, if anyone else is having issues visualizing this map, let me know. We've had a few occasions, especially with Windows users, that we're having issues. So if you're having issue, let me know, and I can help you out.
Question, if I wanted to toggle the yield map off, how would I go about doing that? Could I just comment something in the chunk off, or
So
how?
here, if you come on that stack symbol, you should see the yield layer there. And if you just uncheck it,
Yeah.
Yep.
Yeah.
all right, we finished our 5 minutes. I'm gonna give you 2 more minutes. As some of you started a little bit after. Mhm.
Yeah, I think there is some main indicator that you want to know why.
Yeah, I mean, what do you think is causing those? All right, our timer is up. Please send your answers to my email, and that's okay if as long as you provided me with some of your thoughts, that's what I'm looking for. I think most of you have sent me your answers, so let's move on here. So I was just checking some of your answers here, and so let me toggle yield on and take a look at it. So what I see on this map here is basically, we have some patterns here that we see these like fingers of lower yield cutting through the field. We see this spot right there on this western, northwestern side of the field. We also see that there is low yields at the edge of the field, right? I guess all across, especially if you zoom in, you see like wherever the combine, or in this case, the picker was turning, we see lower yields there. Right, and then if we just try to explain these low yielding areas, I'm just gonna turn off the yield just so we can see. I guess most of you mentioned erosion on this field, right? So we do see that these fingers of low yield happening east-west are actually eroded areas of this field. And we can see that just by this pattern where water is washing off and is taking soil with it. So perhaps the soil here has lost topsoil. It may have been facing a hard pan, or like a horizon below the topsoil that could be impacting here yield points. Also, something to notice is that, so this field and this data here were provided by Dr. George Velides, who has worked extensively in this field for his research program. So he actually has experience with the field himself. I have never been to this field, but just worked with a lot of data from it. But something that Dr. Velides was mentioning to me was that there may be a couple of reasons why we have low yields in these eroded areas here. So one of them, because it is eroded itself, but also because it makes a little bit of a dip in the field, where as the picker is moving across it, it has to decrease speed so it doesn't bump, right? It doesn't it's not a smooth ride to go over them. So the picker has to slow down to go over them. And because of that, there may be actually some confounding effect of the speed being reduced along with the fact that it is also eroded. This part of the field here, it's interesting because we can really see this low yielding point on the yield monitor data, and it is actually also appearing on the on the field itself. This is also a lower lying area of this field. So that also accumulates water and therefore reduces yield. And then across the border again, like if we just notice all across the border, there are lower yielding points. And these could basically be because of the picker not being harvesting all the rows that the picker has, just because it is at that border. And so it doesn't have the head full here as harvesting the border on the sides, and that may be causing those lower yield points. And also wherever the picker is turning, the same thing, right? So it doesn't have a full head here as harvesting towards the end of the rows. And so as it is turning, it's giving us those lower yield values because of that. So we can see here in this field that there is a very different things that are potentially causing yield points. At least we are talking about low yielding points, but of course there's also high yielding points that are erroneous in this field, and that's what we're going to get to in the next exercise. All right, so as the last point of this script here, I do want to export this layer that we used, right? So this is called EO17W. We want to export that to file. That's going to be our last step here. Let me ask one of you, what function should we use here to export this? What did you say?
Right.
Right, okay. Right, what? SF, right? Right SF, because it is an SF object. So the first thing that we give it is the object name. That's EO17 underscore W. Make sure you give it the W option because that's the wrangled version. If you give it a comma, let's break code a few times. And I want to export this to data. Right now we are in code, so // If you hit tab, you can navigate to data. I want to call this yield 17 underscore processed. So that's the name, and then we give it the extension. At this point, we could choose to export as either shapefile or GeoJSON. I do want to go with the GeoJSON just to keep things tidier and less files to handle. So you can just say .geojson. Also, every time that we're exporting an SF object, let's include this argument called delete underscore DSN and change that to true. So if we ever run this line of code or this chunk here more than once, we're not going to append, we're going to overwrite, which is what we want. And let me tell you how I found this out. So this, for some reason, the default behavior of this argument is false. So it means that it appends. And there was, I was teaching this class here for the first time, and I noticed that a student submitted me a summary where they had like almost 64,000 rows. And I was looking at that, and it did not make any sense. Like how did they duplicate the number of rows? So then I was checking through it, we troubleshooted, we spent a lot of time, and then we realized it was because here. So that student basically ran this code here twice without that delete DSN equals to true, and that appended what he had originally wrote. So it basically duplicated all the rows. So this is just a good practice. Every time you're exporting write SF, you use delete DSN so you don't fall into that issue. If you run this, you should have now, if you come on the Files tab, you go on the R blue button, you should have on your output, or I'm sorry, in your data folder, you should have this new layer called EO17 process.geojson. So next exercise, we're going to be using a different separate script. Still going to be the same project, but a different script in which we're going to start off importing this data set here. So I do want you to have that exported from today. In next class, we're actually going to do the yield editor cleaning side of things. So it's still going to be wrangling, I guess, but it's going to be more in the sense of cleaning the erroneous data points, comparing the raw yield data with the clean yield data, see how things are changing, and just create that understanding of how, where, and when these errors happen and why it's important for us to clean them out before we use this for decision making. Okay, so I think that was it for the exercise, at least. I do have a couple of things I want to tell you. So one of them is I have already uploaded or updated our GitHub repo to include the script for next class. You don't have to do it right now, but please do that before next class period. So we're going to start the class already coding. We're not going to take the time to do that in class. So make sure you download the repo. There's going to be a new partial script there. Copy that script inside of the code folder of this project. So you do not have to create a new project. We're going to keep using this 07 EO minor project. I just wanted to copy that new script inside of our code folder here.
Professor.
Yes.
So when you're in data, when we just exported it, I noticed you have 3 files over there on data. 07 yield 17 CSV and yield process, and then is that clean? That should be something that we should have there?
So the clean, I think it's actually going to be our final clean data. Yeah, so you should not have that one yet. That's what we're going to create with the next script. Yep. Okay, so before we wrap up, I do have a very important thing to ask you all to do. Later in the semester, we're going to be pulling open source, or perhaps not open source, but open source to us, free satellite imagery to work in this class for this field. for you to be able, so one way that we could do that is I can give you the images and you can work with them. While that is simpler, I do not want to do that because I want you to learn how you pull satellite imagery, because then you can do this for any field that you wish. With that in mind, I do want you to have access to be able to pull the satellite imagery on your site. We're going to be using, if you have not heard of them, it's a satellite company called Planet. They have a research license. So normally they do not give imagery for free, but they do have a research license that we can all sign up for and have access to. So I do want to show you how you sign up for that. So the name of the company is Planet, and I think they have like a Planet research license. Let's try that. Okay, so it's called Education and Research Program by Planet. So if you come here, you click on that, Education and Research Program. You can click on this Apply Now button, and that's going to take you to this form where you can just fill it up. It's going to ask you for your first name, last name, your university email. It has to be your UJ email, otherwise it's not going to give you free access. Your university, country, a link to online content related to project. So a link to online content related to project, I guess you can just say not available because this is for a class exercise. A link to your university or department website, you can give the Crop and Soil Sciences department website here, or if you're not in crop and soils, you can give whatever is the website of your department. Provide a link to more on your background. So you can give here maybe your LinkedIn if you have one, or your ResearchGate or whatever is your professional social media. Your role at the university is going to be student. The project that you are going to use here, you can say is for a precision agriculture class related project. When it's asked, I plan to use Planet Data for, you can say, let's see, this is a drop down. Yeah, this is a drop down menu. So it would be, you can say both research and teaching, because then that also, you can also use this for your own research if you want. We're going to see how to do this in class for teaching, but you can also apply this to your research. The geography that we're planning to investigate is going to be, maybe like, you can say 5 to 10 fields in Georgia. That's our geography. In class, we're going to be using one field, but I'm just saying 5 to 10 fields in case you want to use your license for your own research, so you have space there. How do you plan to publish your results? I mean, probably peer review manuscript at some point if you're a graduate student, and if not, I mean, you can choose other perhaps. And how did you hear about it? You can say it was other as well. So it's not very complex. It just has, a handful of questions that you need to go through. There's really not a like right or wrong answer. Just as long as you keep in mind you're doing this for class and potentially for your own research as well, this is what you can just fill in those questions, and then you submit this. Once you submit it, I think it may take a little while, perhaps up to a month before they approve. So you're gonna get an email saying like your license has been approved. Here's your login information or something like that. And that's what we need. So again, we're only going to be using or pulling data from Planet later in the semester. So I think you're all going to have enough time to have access to this. If it happens that some of you got access, others did not, I'm just going to provide the imagery then for those that did not get access. I do hope and expect that you all get access by the time that we run this exercise. So whenever you do get the email from them, please keep that in mind that you were approved, because at some point in the semester, I'm going to ask you if everyone was approved and are able to access their accounts. So make sure to bookmark or to, flag or do something with that email, because you do want to have a reference for that. All right, I think that's all I have for today. If anyone has any questions, I'll be here for the next couple minutes. And if not, we're good to go.
Uh, Dr. Jesperson, I would like, sorry, Dr. Bestos, I would like to ask you one question.
Mhm.
Regarding the same thing that I asked you on GitHub, I have all the data for 2022. But in my first question, when I run the entire list, the latest year is 2023. So should I mention 2023 in the first question and do the remaining on the basis of 2022? Or should I mention 2022 even in the first question?
So I guess the advice that I gave you was to drop the years that had an A. If you do that on the wrangling before you start answering questions, then you're not gonna have 2023 in that data set. Does that make sense?
I'll try.
Let me just stop recording, then we can talk about it.